Welcome to my Nanjil Chemistry YouTube channel. I am John Wensley. In the previous class, I discussed types of crystal and classification of crystalline solid. Today, I am going to explain crystal lattice and unit cell. Crystal lattice and unit cell. So regular three-dimensional arrangement of point in space. Three-dimensional arrangement of point in space is called crystal lattice. Then unit cell is the smallest, that is smallest fundamental, that is the basic, repeating, that is come again and again. Portion of a crystal, or a basic repeating structural unit of a crystalline solid. That is unit cell, basic repeating structural unit of a crystalline solid. Then the unit cell contains, that is, first what are the parameters of a unit cell? Draw a unit cell. That is, first a cubic unit cell, that is 4 square, it is 1 square 4 sided, then another draw another square, connect the corners, it contains crystallography axis, OX, OY, OZ, then edge length A, B, C, the interfacial angle alpha, beta, gamma. So what are the crystallography axis? OX, OY, OZ, edge length A, B, C, interfacial angle alpha, beta, gamma. Then what are the points in the unit cell? That is, first draw a square, then it contains 4 corners, then draw another square, it contains 4 corners, then connect corner 8, then face 6, The face mean the planar surface of the crystal. Planar surface. Here, this is one planar surface. This is one planar surface. This is the rectangle. This rectangle is the one planar surface. Then the left side, one planar surface. 2. Then right side, one planar surface. 3. Bottom, one planar surface. 4. Then towards the viewer, one planar surface. This is this surface, the square surface. 5. Then another one square surface that is pointing outward, that is behind the viewer. So totally 6. So total faces 6. Then edge. How many edges in the unit cell? So how to represent the edges mean? First draw one square. This contains 4 edges. Then draw another one. This contains 4. So total 8. Then connect the corners. 9, 10, 11, 12. So edges 12. Center, edge center. So this square contains 4 edges. So this is edge center. This 4, this square. Edge. Then 1, 2, 3, 4. So total edges 12. That is the end to work out problem. That is, these points are very important for that. Edge center, edge center. Then face diagonal, face diagonal. This is face diagonal. Face diagonal. One face diagonal, face diagonal. This is another face diagonal. So each face 2 face diagonal. So face diagonal 6 into 2. Each face 2. So total 6 face. That is 12 face diagonal. Then body diagonal. Body diagonal 4. Total body diagonal 4. So this is body center. This is body center. So this is the body diagonal. Body diagonal. Body diagonal totally 4. So corner 8, face 6, edge 12, face diagonal 12, body diagonal 4. So not mug up. You draw the cube simply. At first draw one square, then another draw one square, then posted the corner, 8 corner, then this corner are joined. So 8 plus 4, 12 edges. Then face is the planar surface of the crystal. So totally how many? 6 faces in there. So face diagonal, each face 2 face diagonal. So total face is 6. So 6 into 12, 6 into 2, that is equal to 12. Then body diagonal, that is 4. Then corner is shared by how many? Other corner item, that is other unit cell, corner. So see my hand. Join this 2 finger, 2, then 2 finger in this direction, that is in the opposite direction, parallel direction, 2. So total here 2, here 2, 4. Then above which 4. So if you join the 2 then here 2. So total 4, the above which 4. So one corner atom is shared by 8 other corner atom. 8 other corner atom. Then the contribution is, corner is shared by 8 other corner atom. Contribution is 1 by 8 per unit cell. Then total phase 6. So let us imagine this is the phase of the crystal. Phase. It is shared by. So phase is shared by 2. Phase is shared by 2. Contribution per unit cell is 1 by 2. Then so see, this is edge. This is the edge of the hand. That is, imagine this is the edge of the crystal. Connect 1, 2. Now it is 2. 2 more. Like this. 2 more. So one edge is shared by 4 other unit cell atoms. 4 other. So the contribution is 1 by 4. Unit cell containing corner atom. This is corner. This part is known as edge. The center part is known as edge center. This part is known as, the surface is known as face. The center is known as face center. Then the center of the crystal, this one, this star, this one is body center. Then also face diagonal 12, body diagonal 4. So total corner 8, shared by 8 other, contribution 1 by 8, total phase is 6, share by 2, contribution 1 by 2, edge 12, share by 4, contribution 1 by 4, face diagonal totally 12, body diagonal totally 4. Then next, unit cells are classified into two types, that is primitive and non-primitive or centered. So what is the difference between these two? That is, what is the difference between primitive and non-primitive? Here the consists particle, that is atom or ions or molecule, that only in the corner, the particle only in the corner. Here in addition to corner some other points, that is in primitive simple cubic, non-primitive body centered cubic crystal BCC, face centered FCC, then end centered EC, end centered. So here SC, atom only in the corner. Here in addition to the corner, center of the body, that is body center. Here in addition to the corner, face. Here in addition to the corner, one constituent particle is present at the center of adjacent, center of any two opposite side, these two or these two opposite side of the faces, that is end centered. Then totally 14 possible 3D lattice called Brevis lattice. In this, 7 of them are primitive. 7 type of primitive unit cell. 7 types of primitive unit cell. 7 primitive unit cell. It is very difficult to memorize it. So a trick, that is, chief minister, chief minister tell us, and his two children, namely Oliver and Tirupati, have HMT watch, HMT watch. It is C T O T H M T, C T O T H M T, C T O T H M T, C T. That is simply C T O T H M T, C T, cubic. T, tetragonal, orthorhombic, O, orthorhombic. Then trigonal or rhombohedral, then hexagonal, monoclinic, triclinic. What are they? Cubic, tetrahedral, tetragonal, orthorhombic. Here very important point related to NEET and JEE is to relate the edge length, interfacial angle and example. Here the first one, A is equal to B is equal to C. Second one, A is equal to B, edge length A and B are equal, C not equal, B not equal to C. Third one, A not equal to B, not equal to C. Again, A is equal to B is equal to C, A is equal to B not equal to C. Then the last two, the third is like, the sixth one is like that of third one, A not equal to B, not equal to C. Here also A not equal to B, not equal to C. So the first three, then next three also same sequence. Then interfacial angle. So the first three, alpha is equal to, beta is equal to, gamma is equal to 90. Second one, alpha is equal to, beta is equal to, gamma is equal to 90. Alpha is equal to, beta is equal to, gamma is equal to 90. Then the fourth one, alpha is equal to, beta not equal to, alpha is equal to, beta is equal to, gamma not equal to 90. Then alpha is equal to, beta is equal to 90, gamma 120. Then alpha is equal to, gamma is equal to 90, beta not equal to 90. Then the last one, alpha not equal to, beta not equal to, gamma not equal to 90. So the tricline is very important, this one. Here all of them are not equal. The edge length also, A not equal to, B not equal to C. Here are the interfacial angle, alpha not equal to beta, not equal to gamma, not equal to 90. Then the example, cubic sodium chloride, common salt, and zinc sulfide, that is zinc blend, zinc sulfide, ZnS. Sodium chloride, common example of cubic crystal system. Then tetragonal tin oxide rutile, TiO2, that is orthorhombic, rhombic sulfur, rhombic sulfur and barium sulfate. Barium sulfate, rhombic sulfur and barium sulfate. Then trigonal or rhombohedral calcite CaCO3 and cinnabar, the ore of mercury, that is HGS, cinnabar. Cinnabar is an example of trigonal. Then hexagonal, graphite, zinc oxide and cadmium sulfide, zinc oxide and cadmium sulfide. Then monoclinic sulfur, sodium sulfate decahydrate, Na2SO4 10H2O, Na2SO4 10H2O, sodium sulfate. Then the last one also important, potassium dichromate, K2Cr2O7, potassium dichromate, copper sulfate pentahydrate, not anhydrous, copper sulfate pentahydrate, CSO4 5H2O. Then boric acid, H3BO3. So in the previous class I discussed about the intermolecular forces of attraction. Based on this one homework, that is right. Classify the following solid in different categories based on the nature of intermolecular forces operating. What are the nature of intermolecular forces? Intermolecular forces in the following. 1. Potassium sulfate. 2. Tin. 3. Benzene. 4. Urea. 5th, ammonia. 6th, water. 7th, zinc sulfide. 8, graphite. 9, rubidium. 10, argon. 11, silicon carbide. So in the following, find out the nature of intermolecular forces.